guys, my name is Ariana and today we're going to work on factor trees. So I'm just going to share my screen so I can draw, so share. Okay, so factor trees are used to find the like the smallest numbers that are possibly used to get a product. So let's, for example, let's see how this is going to work. Okay, so let's start with a number. So let's just do 75. 75. Okay, so 75, let's change the size of that. So what are like two factors of 75? So the first ones that I'm thinking of are 3 and 25. I'm going to put text here again. So I got 3. I'm going to move that. Okay, and then 25. Okay, so 3, there's no other numbers that's prime number. There's nothing else that goes into it aside from 3 and 1. But 25, there are still factors of that. So from 25, the two smallest numbers that I can think of, 25 isn't a prime number because not only is 25 times 1 a way that you can get 25, but also 5 times 5. So 5, let's make that smaller. So these are this is the factor tree for 75 because 75 equals 3 times 5 times 5. So here is our factor tree for, here's our factor tree for 75. So I'm going to just do one more. So let's maybe do a bigger number. I think that we can do 128. So 128 So 128 times 16 is equal to 128. So we're going to take our arrows again. And so both 8 and 16 are not prime numbers because they have factors other than just 1 in the number itself. So we'll start with 8. And so the two numbers that I would use to find 8 would be 2 and 4. Just going to draw the arrows for both right now. So 2 is a prime number. So that one is done, but we have 4. And then also for 16, 4 times 4 is equal to 16. So since 2 is a prime number, that one's done, but we can still, there's still more factors of 4. So for all of these 4s right here, the smallest factors, the greatest ones actually are 2 times 2. Sorry, it's a little difficult. So using the same thing that we did before, the text for this would be text for this would be 128 is equal to, let me change the size. I'll just do it afterwards. 2 times 2 times 2 times 2 times 2 times 2 times 2. So that's 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. And that is our answer. So factor trees are used to find like the prime factorization, I guess, of a product. I'm trying to see if there's another good example. But yeah, so a factor tree is a diagram that is used to determine the prime numbers of a natural number that's greater than 1. So so yeah, it's just helping you get the prime factorization of that number. And you can tell that's because like 2 is a prime number. So the way that that's factored is using only prime numbers. And your prime numbers are like 2, 3, 7, things like that that only have a factor that itself. 11 is a prime number. I think that would be a good example to do. So actually we could do we'll do a factor tree for 121. Because that is something that I think would be useful to do. Because 121, if you know, 121 is 11 squared, so that's 11 times 11. And since 11 is a prime number, the factor tree for 121 would still only be 2 numbers because its prime factorization is just 11. 11 times 11. 11. And so then that would be equal to 121 equals 11 times 11. So yeah, that's how to do factor trees. I hope this helped. Sorry about the delays, but anyways, have a great day.